connecting to the. There we go. Welcome. My name's Kate. For anyone who I haven't met, I think I know almost everyone on this call. Super excited for another webinar this evening. Today we have Alexander Karan joining us, who's going to be teaching us and running us through all about APIs. I'm actually really excited to learn a little bit more about APIs this evening. Alexander has been with us, I want to say, 4 or 5 years now. It's been a
Yeah.
hot minute. It's been a hot minute. Is one of our lead mentors for Perth, has been teaching in React, and does lots of cool things in the cloud space at Atlassian, and is also super passionate about sustainability and the environment, and being an all-round cool guy. So with that, I'm going to pass over to Alexander, and we'll commence the masterclass. Welcome.
Thank you, Kate. That was a very nice intro. Yeah, so look, my name is Alexander. And like Kate said, I actually am the lead mentor for the React and JavaScript part of the course. But I'm actually a back-end engineer, even though I teach front end, so that's a barrel of laughs. But that's because JavaScript is one of my languages, and I really love it, and you can build everything with it. But we're not here to talk about that. We're here to talk about APIs. And I do believe most of you are starting your Python part of the course where you're building your APIs and you're going to be building this system that once it's finished, then you get to plug it into the front end and make it look all cool and do stuff, right? So you're about to hit like the really cool part of the project, because you're actually really building stuff. So it's really good fun. But you've got to design an API, and that's tricky. So I thought we might just go over a few bits of terminology, and I've also got a few friends to write some articles for some handy resources to give out as well, because that's always good as well. But we can use the polling system, so you don't need to turn your camera on if you don't have it on. You can just speak once you've, because I think when you raise your hand, it still comes up. But I guess the first thing is, does anybody know what CRUD means when I'm talking about an API? So that's, CRUD. Anybody got any idea what that means? We got any raised hands at all? Anybody in the chat? No? Have a look. Okay, cool. That's fine. So CRUD stands for create, read, update, and delete. And like it's a common way of describing actions that an API might do, right? So I might have an API endpoint that is to do with books, right? So, and that API might be able to do CRUD actions, which is create, read, update, and delete, right? It's got a really terrible name, CRUD. I don't know what that means in everyone's language or reference or history, but for me, like being from Northern England, it means dirt on the bottom of your shoe, So it's a really weird name. But we sometimes confuse that with APIs, right? So CRUD is actually normally to describe database actions, not an API layer. An API is describing like what your computer program can do, right? Like it's a journey that you take whoever's using it on. So let's start with some drawings and some whiteboarding, just explaining what kind of happens. And if you have any questions, please just speak out or raise your hand, and I will answer them and go into detail. It's really, really important that you ask questions if you don't understand anything, or you're curious. It's really important. Even now, at my level of been coding for 14 years, asking questions is so important all the time. So you please ask questions, interrupt, and I will explain. So anyway, let's share my screen and jump into this. Right, so can everyone see my nice little whiteboard here? Is that good? Yep, cool, great. Okay, so when we have a API or what we're building, this system, uh, you normally actually start with a web browser, right? So like someone goes to your website and loads it in their web browser. So we also call that the client, right? So bear with me, my spelling is terrible. Now that client will make a request to your server, which has your API on it, right? Like this is how you're going to build it as sheet codes. You're going to build your Python server and you're going to build your React web application, right? So your server is going to sit over here. And since you're writing it in Python, just going to call it your Python server, and this is your API, right? So your browser is going to make a request, right? So it's going to go up, and maybe what it's going to do is going to go, hey, I want to get all the users, and we'll come back to why I've spelled get like that in a minute. And that's called a request, right? Your client is making a request to your API, right? And then your API will send back a response, right? Although that doesn't, there you go. So that's the basis of this relationship, right? Like, and a client, this is the sneaky part, can actually be anything. A client doesn't have to be a web browser. It could be another server. It could be a IoT device like your a Siri speaker or Alexa speaker at home, right? Anything can call an API. A machine can call an API. Maybe you write a bit of code that calls an API, right? Like so, anything can call your API. But generally, this is how I have like a client or make a request to the API and you return a response. Now, there's many different types of requests for an API. So there's kind of four key requests, and this sort of aligns with HTTP methods, right? So if we go to, I'll put this in the chat as well. So if we go to Google and we type in HTTP methods, right? So we go to MDM web docs. These will be your best friends, the web docs. They're great. So these kind of list principal HTTP request methods, right? So HTTP is a protocol for communicating over the web, but you don't need to remember that really. We can go into that later. It's one of those things you hear and you can pick up somewhere later down the road, right? So HTTP is how we communicate. It's a protocol for machines going, hey, this is how we talk and do stuff, right? So there's a few different types of requests in here that we need to listen to. So I'll just quickly pop that into the chat. So HTTP requests, there you go, for anybody who wants it. Right, so there's a few different types, right? The first one is called GET. And this is, make sure everyone can see that. This is your bread and butter. And this literally does what you think. It gets something, right? Like it goes to the server and brings it back, right? That's what it's called, get. Yeah, that's the easiest one, thankfully. And then your next one is post. So a post request, right? And this is creating something. So you're creating something in your API. So this is getting something. Post is creating something. And then you've got two others that are like post, right? You've got, because, let's be confusing, put and patch. Now, you've actually got way more than this, but we're only going to cover a few that you will need. Now, put and patch are a little different, right? So get something. Post, let's actually do this because I feel like get is clear, but post isn't. So that is creating something. And put, right, is where you update something. Okay. And patch is where you update something, right? So just to be confusing. But there is actually a little difference between these. Patch is the official update, right? So let's say I have a user and we're going to update the name on the user. That would be a patch request, right? Put is where you're replacing that object entirely, right? So like if I do a put request, I'm not updating part of the object or the user or whatever it is. I'm completely replacing it. Like it ceased, what was there before ceased to exist. A really good example of a put request, right, would be like a profile image, right? When you upload your profile image, the old one ceased to exist, right? You're replacing it with a new one. Or what's another good example? Like maybe you have, let's say you have an API that deals with film scripts, right? And film scripts go through lots of iterations, don't they? Like version 1, version 2, version 3. If you're when you make a new version, you might make a put request because it completely replaces the version that was there before, right? Like it's not updating it, it's replacing it. So that's something to remember. So replacing. So you might not use that one as much. And then the final one that we need to know about is actually wait, I just made that red. That shouldn't be red. Here we go. The final one you need to know about is delete. And that's pretty clear as far as I'm concerned. You're deleting something, right? Um, and those are your basic methods, right? Your basic requests that you can be making to an API. Now, I'm not going to delve into code here because there's many ways to build these things and do the requests, and that's going to be the job of your mentors. What I'm going to talk about is how to think when you're designing an API, right? Like you're going to have to build an API. I don't know if you've been given the details of the project yet, but like that's based around projects and pledges, right? So, and users who have projects and they're taking pledges of some sort. So you need to think about building out that API. Now, there is some fun, cool stuff for this, right? So there is actually a way to describe APIs. This is a big thing in software development, and that is to be super confusing. It's called Open API, right? Which is, now we have Open AI and everyone gets confused. That's great. So I'll just put that in the chat as well. Right, cool. So that's there. But you guys don't need to worry about this right now. It's not something that I would expect any of you to use because basically it's like a spec. It's a format for writing and describing API endpoints that is very common in the industry. A lot of tools have like friendly ways of writing APIs and then they export this spec on the way out. So it's just something to know about. It's not something you need to learn because it can be quite daunting to learn. I mean, I've got to the point where I can just write stuff in the spec raw, but that's because I do this all day. But yeah, so that's something to read about. They've got lots of helps and FAQs and guides and stuff about what Open API is and how to do better APIs. But we're not going to focus on that. We're going to focus on designing an API, right? So let's. Does anybody want to screenshot this bit before I scroll down? Just give you a second in case you want to. I will
Alex,
export this as well.
I
Yes.
have a Figma board that I have collated stuff for this module. So in terms of the students who are listening, I'm sort of typing up what you're doing. So there's a record of what you're drawing.
Oh, that is brilliant.
As a
Thank you
side
so
note.
much. Yeah, that's great. Okay, well, I will export this as an image as well at the end, but yeah, that's even better. Right, so let's think about this, right? There's one kind of thing that we've touched on a little bit, right? Is when you're designing an API, you design endpoints, right? To make requests to. And what do I mean by that, right? So let's pretend we'll go back to this example that I was using before. You've got a API that tells you about books, right? So you're going, okay, what does my API, what is it made up? What are the resources or collections? Now, what does a resource mean? So a resource is something people can get from your API, right? So if my API is about books, well, you'd be able to get a book from it, right? Like it should return details on a book. But what else? What else might it do? Well, I guess there would be authors because books have authors, right? So that would also be something that those off the top of my head, I'm sure there's going to be more. There's always more, but like if I was building an API around books, these would be the resources of my API. But then how do I structure those? How does that fit into the wider scheme of things? Well, it might kind of go like this, right? So I might be like, okay, let's build an endpoint. So an endpoint is the web address of your where to get the information from. So this is kind of have to go. We're going to delve into URL stuff for very briefly, but let's say your server is located at api.shecodes.com.au. Actually, it's just .au now, isn't it? I think. Yeah. Anyway, let's say that's where your server is located. So that's your base URL, right? Then all your API endpoints would come after that. So we might have like books, we might have authors, and they're going to return data, okay? So let's forget about the base part of the URL because we don't care about that, like we're not coding. Let's think about our API endpoints, right? So I'm probably going to have probably going to do a GET request at /books, right? Because that will give me all the books. You know, makes sense, I guess, right? Next, I might have, because what if someone wants to get a single book, right? So we might have books/ID. And I've put ID in little brackets like that because it implies that you need to put the ID of a book to get a specific book. So here we're saying, oops, 1 second. Here we're saying return many. And here we're saying return one, right? Can you see? So that like there we're getting a rough idea of what this API structure might look like. But then we know we'll have authors, right? So we've got authors. How do we want to structure that? Like that's also something. So I guess we could do something like this. We could do books/ID/authors would return all authors, right? But to do with this particular book. But maybe we also want to give users a way to get all authors. So we might do /authors, which returns all the authors in our API. Anybody got any questions? A bit lost so far? Any questions? I'll just let me check the chat as well, because that disappears behind the window. No, all good. Okay, remember, if you got any questions, just reach out and pester me. So this is quite simple, right? We've got books, we've got get a book by ID, we've got get authors for a certain book, and we've got get all our authors. Seems straightforward, right? Like this is a good way of thinking about it. Now, we're going to delve into objects in a minute, but I want to be clear as well. You're going to learn about databasing and building a database when you build your backend. What the data in your database looks like and what the data your API returns can be very different. In a database, data can be stored in lots of different places or tables or collections, depending on the type of database you're using. Your job as an API, right, is to build that data together to create something consumable for the clients. So just keep that in mind when you go further into your course and you delve into the database and the API, right? They're not supposed to be the same. You can make them different. So we now need a way to make a book, right? So what if we're like, hey, we've just published a new book, someone needs to make a new book? Well, we can sort that out quite easily. We can just go over here and turn this into a post request. Bam, there you go. And then we can do the same sort of thing. What if someone needs to update the name? Like, what if the name got changed? So we can go, okay, well, we'll make sure there's a patch request to book/ID. And then we're like, oh, what if someone actually accidentally adds a book that shouldn't be there? Well, let's add a delete request, right? Now, a delete request probably won't return a an object because it's deleting. It might return a success message, but it's not going to return anything really. So there we go. All of a sudden, we've got a nice little API, and we haven't even started thinking about what the data is going to look like. We're just thinking about the endpoints and routes. And you can probably see how this might fit into your projects and pledges thing as well, right? Like you kind of have a structure there. So here we're just thinking about endpoints. We're not thinking about objects yet. We're just thinking about those endpoints and those actions users are going to want to be able to make with our API, right? So this is where it starts to get a little tricky though, because now we need to think about what's the data going to look like? How's that going to map to the stuff that we return? So does anybody know what JSON is? Anybody want to shout out or jump in the chat and tell me what JSON is at all? Anyone got some ideas? If it
JavaScript
helps, I don't.
object
Oh,
notation.
that great, cool. Look at that. I don't even know what it actually stands for anymore. If that helps, like I'm just like, oh yeah, it's just that data that gets sent by systems, you know. So there's actually a few different ways of returning data on an API, right? There is XML, there's JSON, I think there's BSON, there's a few libraries used, which is binary JSON, and there's a few other formats too, right? But JSON is a very common format for sending and receiving data. Okay. Now, what we're actually doing here as well is we're designing a REST API, which is REST, like as in go to sleep. Now, there's a few different types of APIs, right? There's REST, there's GraphQL, and there is async APIs, and there's probably gRPC as well. Just forget I said gRPC. We can talk about that later. An async API is an asynchronous API, which it means it's an API built for event-driven services. So it's not something that you call and get data back. You call it and it goes off and does stuff, right? Like it's so once again, forget about that too. So the two main APIs you're going to come across are REST and Graph. A Graph API is a query API. And the way it works is it allows a user to build all their queries on the front end or in their client, right? They can decide what they're going to get and what it returns. In a REST API, you decide what a user can get and what a user returns. And there's pros and cons to each approach. I mean, I prefer REST. I've been doing it for a long time. If it's done well, it works really well. But yeah, obviously, it's not always the best fit for everything. But this is what you're building. You're building a REST API. And so when we think about that, when we think about those resources that we're creating, the thing that makes something truly RESTful, right, is not that it's stateless, but that it actually has something called hyperlinks or metadata in it. And what I mean by that is that, you know, the resources you return refer to each other. So someone could call your API and understand what it does and what data they can get just by looking at the data. That's what a true REST API is. To be honest, most people never reach that. So most REST APIs are REST-ish. I think is the best, like they're almost REST, but they're not. But anyway, we're just here to have fun and learn. So just remember, none of that matters. So just, you know, try your best and experiment and see what works. But a little bit of background information. So let's think about what a book might look like, right? So we're going to return a book from over here. What might our book object look like? Well, if it's going to return JSON, it's probably going to look something like these squiggly brackets, right? And then we might have a ID, right? So something should have an ID, right? Like it's got to have an ID. That's how we identify it. That's how we return the book by itself, right? Because we'll take that ID and put it into the next URL. So it's probably going to have a name, right? So what's my favorite book? I'm reading this really cool book at the moment called Black Pill, and it's about how like all I suppose it's a bit dark, but it's about how like all the messaging boards like 4chan and 8chan and how that hate and bile has become part of mainstream politics. It's very sad and scary, but an interesting read. But anyway, so then you might have the author, which I can't remember off the top of my head. Also, by the way, I'm heavily dyslexic, so there's a chance there's going to be spelling mistakes here. I think it's Ellie something. I'm just going to put LEG for now. And then maybe we'll have release. Actually, whoops, I forgot to put that in comments because it's JSON. Release year, which will be a number. So let's say 2024. Right. Cool. So you can see here we've got an object, right? We've got, this is kind of the object my book API is going to return. Remember, just keep this in your mind. It doesn't matter if Ellie Reed, thank you so much. Thank you, Kate. She is great. She's such a good journalist as well. Yeah. Anyway, so this is the object, right? Like this is what we're going to return. And remember, it doesn't matter if my database doesn't look exactly like this. I can put data together to make this happen. Now, this is really great. Like, basically when I get books, it's going to return an array of these, right? So it's going to be like, the square brackets for arrays or lists. Do you call them lists in Python? I think it's lists, right? So it's going to return that, right? Like it's going to return a list of these objects. But the problem I've got here, though, if I think about it, is the author is just a name. It's not an ID, right? So because if we take the author thing further, surely we should be able to go like this and pop in the ID and get the rest, get a single author by ID. So if we want to build a really good REST API, what we can do is we can do a few things like this. Instead of author being a string with a name, what we can do is we can go, well, actually, author has an ID in it, right? Which let's just say it's one, and it has a self. So you could call this self. You could call it link or whatever. I'm going to call it self. This is quite a common approach, and that is authors/one. Just make that a bit bigger so it comes out all the way, right? So what that implies is like when someone gets this object back, they're like, okay, that's the author, and the self is the URL it needs to go fetch that data at. Does that make sense to everyone? So we're implying, hey, this is an object that's in my API, and you can fetch the details over here. Now, some people put this in as links as well. Like they call this link. Some people also, instead of doing here in author, they just put the ID, and then they have like a link object down here that has all the links and stuff in. The way I've done it here is quite a common approach. And it's actually one of the best approaches in my opinion, because it also comes up in, what's this payment? Yeah, okay. So I don't know if any of you have heard of Stripe, but Stripe are a way of managing payments, and they have one of the best REST APIs ever. It's so good. So you can go here and you can see all their different API endpoints. You can see their structure. So you can see here as well, like you have the ID of the customer, and it has some buried metadata as well. But like this is where I get a lot of the stuff that I do from, right? Like when I'm looking at like list all customers, they have this other data in here as well that tells you if there's any more data and stuff like that, right? So there's multiple ways of representing data. So I'll put that inside the chat. So if anybody wants to go look at the Stripe API docs, here we go, because they're always a great reference. They're fantastic APIs. So here I'm implying to the client that they can go fetch the author information from another endpoint. Now, we could, if we wanted to, actually put some of the information in here. We could go, well, you know what, we're still going to supply you with the name because we want to, right? So it was LA. Right, so we could still supply you with the name, but no, normally we don't do that. Normally we're like, that's up to the client to go fetch that information. They know it's there. So we've got a good idea of what our return many will look like, and then our return one will literally just be the same thing, except it won't be a list, it'll be a single object, right? Like so. Bam. Now, sometimes some things people do as well, right, is in the return many, they actually return less data. This is quite a common pattern. So it's entirely up to you how much data you return in your return many versus return one. Return one should list all the data about the book, right? Where in return many, we could go, you know what, we're just going to list that, or we're just going to list, we're not even going to put the release year. Some people even just go, yeah, well, there's the ID. If you want the whole object, you have to go get the whole object. Personally, I just return the same object in my many that I do in my one until I notice a performance issue or requirements change, right? Like it's very rare that I don't do that. But we won't be dealing with APIs that deal with billions of requests a day, so we're going to be okay. So that's pretty good, right? So we've got a basic understanding of how we're designing our API, and then we might do something similar for the books, right? So let's go back to the books. We'll do something for the books, right? So like we'll have a look at the books and we'll go, so we're going to do return many for the books. Now they're going to have an ID, they're going to have a name. So let's go with Ellie. I've already forgotten the surname. We're going to get rid of the author because a book could be, linked to multiple authors, right? Like they could have multiple books, and we could do that in a way like this. Books could be an array like this, so it could be an array or list inside with that whole, then an ID and a self in there. But it's probably, for us, we're not going to do that, right? Like for us, an author is a nested object. So, search books by author and we can go from there, right? So that's there we go. We've got like a nice sort of rough API design. Just there. I do say take everything I say with a pinch of salt because even when there's rules or guidelines, most rules and guidelines get broken in programming. So, and also developers are really opinionated. So I might tell you one thing and five other people will tell you something different. And we always like to think we're right. So at the end of the day, the best thing is whatever gets the job done, and then we can worry about making it better later. So there we go. We've got like a good idea of the objects that we're going to return and how it's going to work, right? So when we return these objects, right, and we return them back, like this is going to be a 200 response, right? So something to think about, although it's not necessarily part of API design, is HTTP response codes, right? So something to have a look at. So response codes are kind of like, oh, this was a good thing, this was a bad thing. So successful is 200 to 299 because there's literally that many codes. I'll just put this in the chat as well. This is not important, but something to have a look at because it will come up when you're building your API. So, response codes, right? Let's have a look at successful. 200 okay. So when we think about our return many and return one, these are going to be 200s. They're going to, as long as everything's working. I mean, if something goes wrong, we might return a 500. I'd be like, oh, database is down, but we're going to return a 200. When we do a post request to create a book, right, we are probably going to return a 201, which means created. And post requests work a little bit differently, right? So if we look at this post request and we go over here and we think about this, a post request actually has data in the request body. So a GET request just has stuff in the URL. In a post and patch request, we expect stuff in the URL and the request body. So we might say, hey, we want you to create a book, you need to send this data, right? You might go, you need to send a name, which is of type string. If you're not familiar with types yet, I'm sure they'll come up as you're doing your thing. String is basically, a character, words. We might release year, which we will want to be a number, an int, which is a whole number, not a decimal number. And then we also might want a author ID, right? So you need to attach an ID of an author that's already inside our authors collection, right? So, but if that's the case, right, like if we're going to need to attach an author ID to create a book, what if a author doesn't exist? Well, now we know that we're going to actually have to add a post request to authors to create an author, right? Because we've got to attach one to create a book, right? Can you see how by doing this whiteboarding and sketching out an API, it gives you a good idea of how you're going to need to build your API and what endpoints you're going to need. So they'll send this in the request body, request. I feel like I'm saying that weird. And then we'll send back this. So on a successful create, we'll send them back the actual book that they create, right? So we'll do some magic in here in the middle of the database, and it will send this same object back to them, right? Bam, magic. Now we can ask for a lot more data. Maybe there's lots of other data that we put into our database that we don't send back to users. Like maybe, what's another thing a book might have? Maybe a publisher, we want to know who your publisher is. And that can be free text, but maybe, we all know that allowing users to have free text in a system can be bad. Not always bad, but sometimes bad. So maybe publisher shouldn't be free text because it's not a comment. And now we're like, okay, we're gonna need to go build a whole bunch of other APIs for publishers, right? Like we're gonna need to be like publishers, and then publisher get by ID, and we're gonna need to put another one here, right? So now we've got the get all, get one, create one. Probably end up needing delete as well, and there we go, right? So bam, like we've got the ability to create an author. And the same thing would happen with a patch request, right? Like a patch request has a body, but maybe you can't update release year. So when you do a patch request, let's copy this over here. Maybe the only thing that you can update, like once a book is out, like maybe the only thing you can update is the name in case it was wrong, like we can put restrictions like that. Who knows? It's up to us. It's our API, right? So, and then that can return a fully updated book. Right. Okay, cool. So we've got kind of gone a rough overview of how this process might work. There's also a few other things that we can talk about, right? Like maybe when we're getting many, so if I'll just bring the books down here, we might want to support some filters. Now, filter is called a search or query param. So maybe we can support a author. So I know we can get a book by ID and we can get the authors for a book, but maybe when we're getting all books, we only want to return all the books for a certain author. So we would support a query param of author on the get all endpoint for the books. Maybe we also want to do this for publisher, right? So we'll support publisher as well. Maybe we also might want to do this for release year. Sorry, there's a little fly flying around my head. Why do they always seem attracted to your mouth? Like there's a whole massive room here. Sorry about that. I'm getting distracted. Anyway, it's a release year, and that will be a number, right? Now, you'll have noticed when I'm writing this URL, I put a dash in my URL because that's URL standards. But you may find that when you build an API or when other people build APIs, they may go release year in camel case. If anyone ever tries to tell you to do undercase, that's definitely not correct. But you can do it. There's nothing stopping you, but it can cause some issues. But yes, try and use dashes where you can because it's more URL standards. So here you go. So that way we can provide filters so you can still get multiple books, but only ones for certain things. You never know. You might find that comes in handy when you're displaying all your pledges on a page, right? So we've talked about resources and collections, right? So collection is getting many of a resource. We've talked about books and authors, but what about actions, right? Like things are going to come up that might not be very like restish, like in the way that we've talked about. Like you might go, I need to build a login endpoint, or I need to build an endpoint that does something that's a little bit outside. It's nothing to do with an object. It's nothing to do with this, right? Like that's probably going to come up. Yeah, I hate flies too. But don't worry, thanks to climate change, bugs and species are dying off very quickly. So let's think about that, right? Like I might have a get request for users where I can get all users. I might have a get request where I can get a particular user by ID, right? But that's still not an auth endpoint, right? Like it's still not a REST principle. Well, don't worry. Like I said before, technically you can do whatever you want with an API. So when you're building auth endpoints or authentication, you might go, okay, I'm going to build an endpoint that goes something like this: /auth /log in, right? And that will return a certain object and hopefully something inside your cookies. So it'll return an object of some type, maybe the user, plus cookies. You'll find out what cookies are when you dig into your Python code. They're delicious. Anyway, so we can have actions that do certain things. That might be a post request. It tends to be when you do an action that isn't like getting a resource. It's not actually creating something. It's just an action. Those tend to be post requests. So things like log in or log out, which might destroy your cookies. In retrospect, I'm saying that, and it just sounds like nonsense, doesn't it? Create cookies, destroy cookies. Anyway, fun times. So you might do things like that, right? So that's quite a very simple API design, right? Like actions can still be endpoints, but they're most likely going to be post requests. But most of your API should be built around the resources and collections that your user needs, and the object should return data about themselves and links to other objects that they create as valid JSON. Now, the final thing I will talk about I'm amazing at destroying cookies. They never last long with me. That's definitely the best comment ever. Yeah, I know. It's so funny. The older I get as well, I still want to eat the cheesecake, but I have to exercise more to stay in shape. It's so frustrating. I wish I was 21 again, where I could just eat junk and it was all fine. Anyway, we're just talking about my life, and that's not important. So the last thing we should probably talk about is these collections, right? If any of you had a keen, quick, fast eye, you'll have noticed when Stripe is returning multiple objects, right? They have these things called like object, URL, has more, and then the data itself is in a data object. This is quite common, right? This is quite common when you're returning multiple objects. The single object still looks like this, but the multiple object might actually look like this. So let's just copy that, and we'll go down here and we'll do something like this. That went really bad. Okay, let's just, that copied it all as different text. Let's do it again from the beginning. So it might actually look something like this. It might have a type, which might be list, right? Then it might have the as more, which equals false, and then it might have the data, which would then be a list, array, whatever you want to call it, of your objects, right? So like that's where your user would be. So your book. So we'll go, name of book, black pill, right? So that would be kind of how you'd structure your data. Now, why do it like this? What does this mean, Alex? Well, this is because a lot of collection endpoints, so it returns everything, are paginated. And what I mean by that is if you think I've got an API, right, that stores all the details about all the books in the world, that's a shit ton of books, right? And if you think about a database having to go and fetch the details on all those books and maybe some details on authors because we've stored it in two places, who knows? We build the API builds the objects, remember? That's going to take a long time. And then the person loading your website is going to be sat there looking at a loading screen for like 20 minutes, right? And that's just not going to fly. They're going to bounce, right? So a lot of the time we paginate data, and we probably do it with something like this, right? Like, so we'll have a links thing, and that'll be an object itself that will give you a URL to the first page in the pagination, right? So it'll be like, books/books, and then page equals 1, something like that. And then there might be something for last, and then, next, and then previous, right? So that will give you links to each of the different pages, right? So the first page, the last page, the next page to the one that you're on, and the previous page to the one you're on, right? But you guys don't need to worry about that. You're not going to be building a crazy API for now. So don't worry about pagination because it is a little bit more complex, but it's just something to be aware of, that it's quite a common structure. So when you're building your API, you could, just return the collection as an array like this, or you could structure it like this and just leave the links part out. It's totally up to you. But, I always prefer simplicity over complexity when you can. So maybe just do that. But something to be aware of, pagination is a thing. And the way it kind of works is a multiple different ways of doing pagination. Actually, if you're interested, further reading, that's right. I spend way too much time on the internet, and I run a website called APIs You Won't Hate because I need to get off the internet basically. But if you're interested in pagination, here's a blog post on some different ways that you can describe and do it in an API. I also we also had one of our wonderful friends APIs do a blog post on resources and collections, which is what I've been talking about, and collections. So all the stuff we've kind of gone over is kind of here in another way as well. So yeah, so that kind of gives you an intro into API design, right? So we've got the basics down. Anybody got any questions for me, right? Like hit me with questions. If you're confused, if things don't make sense, now's your time to ask me. And I will hopefully divulge some clarity if anyone's confused or has further questions. Feel free to just put it in the chat as well. Don't need to shout it out loud. It's up to you. Oh, wow, no questions. Maybe I described everything really much
have a
clearer.
question.
Brilliant.
Hello.
Question. Yes, hit me.
Yeah. So my question is, what are the disadvantages of REST API? Why we use GraphQL over REST API?
Okay, yeah, that's a really good question. Wow, that's great. Okay, so a REST API, one of the reasons people don't like it is because it leads to something called overfetching, right? And you may have been able to see that in the way I was designing. Like when I designed the get book, you didn't have the full author info. So you have to go make another network request. Does that make sense? Right? You have to make 2 network requests. You have to get the book and then get the author. That's 2, right? Now that could be a problem. Imagine doing that again and again all over the place, right? That means it's slower to get all the information on your page, for example. Now, GraphQL API, that doesn't have that problem because you can build a query in your client that gets an author and the book at the same time. So GraphQL kind of gives the API power over to the person who's building the client, in this case, a web app, to write the queries that they want. So they may only have one query. There are lots of downsides to this. It's much harder to do caching in GraphQL APIs. Caching is where you tell browsers and computers to remember data. It's much harder to do that. Security and permissions and rate limiting are also much harder because GraphQL is kind of like one big endpoint, right? So like it's like one endpoint where REST is multiple. So for example, your login endpoint, I might be like, okay, you can only make 5 requests every 15 minutes from this endpoint. But a GraphQL API, how do you do that if it's all one endpoint, right? So it's actually a lot more code to do that. Now, I would argue as well, if you do REST APIs well, and you also build good clients, right? Like if you build good web apps, it shouldn't be a problem. There's a lot of tools out there that can help you build really efficient web apps and do prefetching, which is like you fetch the data before the person needs it. If you're interested, check out TanStack Query or React Query. It's really cool. That allows you to do a lot of that stuff. But yeah, so those are kind of the ways off, right? Like REST API is overfetching, GraphQL is really cool as well. Like it totally has its uses. I don't want to knock it. I never want to knock any technology really, unless it's Java. But you know, because they're all good, right? Like everything is a trade-off basically. I definitely prefer REST myself over Graph. But that's only because I've hit issues with Graph. Is GraphQL just for JS? No, it's not. GraphQL is a specification, right? It's a way of writing an API. It probably seems like it's just for JS because JavaScript developers love GraphQL. Like JavaScript developers have exploded in the last 20 years, and there's a thing called JavaScript fatigue because like every fucking week there's a new framework or a new way of doing it, and they all jump on the bandwagon, and that's now how we're doing things. It's the only downside about the JavaScript community. So yeah, the JavaScript voices are very loud as well, right? So that's probably why it seems that way. I mean, there were other ways of writing APIs. There used to be something called SOAP, which is SOAP, I think it's spelled that way. And they're awful APIs. Like, that's a really interesting way of every time I have to touch government services that have a SOAP API, I cry inside. But yeah, REST is fine, Graph is fine, async is fine, and so is TRPC, but we're not really going to touch on that as a whole other thing. They all have their use cases. Like for example, at Atlassian, where I'm from, most of our external APIs are Graph, right? But a lot of our internal APIs are REST. I've previous companies, REST API, REST API, REST API. It just depends where you are, really, to what you get used to. Yeah. Any more questions for me? I think we're all questioned out. Cool. Well, look, I will be around in the Slack channel over the next week or two because I normally start checking people out before I teach you JavaScript and React in Perth. So if you're in the Perth team, I'm going to be seeing you all in November, but I'll be starting to lurk and see what you're building because I don't actually know Python. I keep meaning to learn it, but then I have to learn another language for work, so I never touch it. If you're interested, my main languages are JavaScript, Kotlin, and Go. I also do Java sometimes, but I need therapy every time I do that, so try not to talk about it. But Python is really good. It's a really fun language to learn. It's really easy. It's used a lot in Australia, particularly because of the mining companies, I think, more than anything else. I mean, we use it at Atlassian too. But yeah, so I'll be around if you've got further questions about APIs. Two types of API to be used merge. Yes, that does happen. Yes. So the question was, is there situations where we need two different types of API to be used? Now, that is 100% the case, right? That can totally happen. For example, a really good example is maybe you have a server, right, that has data and stuff. It might expose a GraphQL API for clients to use, like web apps. But because it's built in a microservice environment, it has to talk to other services. So it might expose a REST API or a gRPC API to talk to the other services. So it'll actually have two API layers, one for the clients and one for server-to-server communication. That's very common. That does happen a lot. Yeah. But I mean, they wouldn't merge themselves, but the service itself would have two API layers. Like it's quite common. We have a lot of services, microservice set up at Atlassian. They expose a GraphQL API and then sometimes use REST APIs or gRPC to talk to each other when they're spun up in the same server. Yeah, cool. That was a great question too. Love that question. Any more questions? But if not, I will be around in Slack, so you can shoot me some messages. Either do it in the public channel, or you can DM me. I mean, it's always good to do in public because then other people can read and learn. It's one thing I'm at work is I'm always like, stop DMing me. This needs to be in the channel to do with this project. I'm also saying that so people know that I do work as well, but whatever. Cool. All right, brilliant.
We can give a huge round of applause to Alexander for running the session today. I know that I learned things. This was really helpful. So thank you so much for hosting. I will stop that recording now.